Well, why are you interested in this class?
I'm really interested in biology, like science in general, but biology is so interesting, just learning about how like living things operate and function, all like photosynthesis, DNA replication, cell replication, reproduction, everything like that. It's just so interesting. Because I'm thinking about going into pre-med or maybe cancer cell research. So.
Oh, wow.
Yeah, like oncology, pathology. Yeah, I like learning about different types of viruses and like why people like contract, AIDS and cancer and all these other diseases, and I want to help, find a cure for them.
Wow, that sounds interesting.
Yeah, I'm just really fascinated with biology, like just, everything that's like really small, like can impact like the whole world, So,
okay.
Yeah, so I want to go into like lab work, maybe medicine, so.
Well, that sounds interesting. You'll contribute to society. So, I thank you for your time.
Oh, thank you so much.
Okay, this is Rex, and yeah, so there.
Hi.
Explain what you're doing.
We're preparing an agarose gel for electrophoresis.
Okay.
Can you introduce yourself? So,
I'm Edith.
Hello.
what's your background?
I majored in physics at UC Davis, and I'm coming back to Solana doing biotech program.
Okay.
Very good. Okay.
So, hello.
Hi, we're doing agar gel. Hi, I'm Dolly.
Hi.
So, Eden, when you're done, when you can hold this in your hand, that's pretty good. You don't want it to get too cold. If it gets too cold, it solidifies and it's a do-over, right?
So this is all set up.
Should be all set up, and just check to make sure that the gasket doesn't have any holes. Good. Okay, go ahead. Pour.
Wait.
It is viscous because it is a high percent. That's very nice. Well done. And then I always rinse this out right away so it doesn't stick. Leave it there while you've poured it. So we'll let it solidify for an hour.
An hour?
Usually what I do is I'll pour these the night before and let them solidify overnight so that the wells are really well cured, and then use them the next day. In the meantime, we're going to look at microscopy, so if you wanted to go get some microscopes. We're going to look at cells. Yeah, just rinse.
So, what are they making here?
One of the main techniques that you use in cell molecular biology, and you've probably done this in Lilibeth Pinpin's class, is electrophoresis. So there are two main types of electrophoresis. One is agarose gel electrophoresis, which we're seeing here. This is a separation technique where you can put in DNA and analyze a mixture of DNAs, separating them out by size. Next week we'll be using agarose gel. So next week we'll be using polyacrylate gel electrophoresis. With polyacrylate gel electrophoresis, you separate proteins according to their size and analyze a sample that contains proteins, and you can tell the number of proteins, the density or amount of each type of protein, and you can tell the size of each protein in the mixture.
Wow, you can tell a lot.
So we're starting out simply on this gel electrophoresis today.
Okay.
And this is everyone, because it's the beginning of the semester of our cell molecular biology class, this is everyone's first experience of pouring it on this gel.
Wow. So this must be fun for the class then, learning about this.
It is. So one of the things that we emphasize is that the skills that you learn in the laboratory part of a cell molecular biology class, you can add to your resume, and your resume then will build, and it'll help you get a summer internship, it'll help you get a job. It really is the most important component of the class, where you're building skills as well as gaining the knowledge of cells and the molecules that make up cells.
Wow. So you guys really do some intense stuff here.
Well, we have, this is probably the best equipped lab, one of the best equipped labs in California.
Wow.
So we spent quite a bit of effort, quite a bit of money on that. Okay, so we'll do that.
Today we're here with the Director of Biotechnology, Dr. James DeClos, here in his laboratory to speak with us today. He's given us his time to be interviewed. So, tell us about what it is you do here.
In this class, we teach both cell molecular biology, which is a prerequisite to our biotechnology program, and our biotechnology courses. The biotechnology program at Solano College is designed to support the biotechnology industry in Solano County. Mainly, what Solano County biotech companies do is manufacturing. So we designed a curriculum that supports their manufacturing effort. At the time that we did it, we were one of the only colleges in the United States, 2-year or 4-year, that had a curriculum that emphasized biomanufacturing, the manufacturing component of the industry. What the students do here is they take genetically engineered cells, they grow them in large numbers, separate the cells from the media that surrounded them, break open the cells or collect media, depending on how the cell has been engineered, and take the proteins that the cells produce and isolate them to purity. The proteins that are produced are human proteins because human genes, human DNA, has been placed into either a bacterial cell, a yeast cell, or an animal cell, and then that cell becomes a manufacturer of that human protein, which becomes the medicine. So in biotech, proteins are the medicine. That's how patients are treated, and that's how biotechnology companies make their money.